Good morning. In this video, we have discussed about the curvilinear translation. Motion in a plane are categorized into three: the translatory motion, rotary motion, and general plane motion. In translatory motion, there are rectilinear translation and curvilinear translation. The rotational motion is the motion about a fixed axis, and general motion is combined motion of rotation and translation. This equipment represent all type of motions. The piston is moving to and fro, this rectilinear motion, and this point is moving along the circular path. So this link is moving in a curvilinear path, and this link is general plane motion, rotation, and translatory motion. And this disc and this arm is moving about a fixed point as rotary motion. This translation, which, okay, see, if every line segment on the body remains parallel to its original direction during the motion. That is, when a body is moving in a straight line and all the points are parallel, then that type of motion is known as rectilinear translation. That is, when the path of the motion for any two particles of the body are along equidistant straight line is known as rectilinear motion, whereas the curvilinear motion, the path is curvilinear, but the points are equidistant. This is an example of curvilinear motion. The passengers on this amusement ride are subject to curvilinear translation since the vehicle moves in a circular path but always remains upright. Consider this a particle moving this path OA at a particular instant of time t, the particle at point P, and at time t plus delta t, the particle at point P1. And as the particle is moving with the time, represented by this coordinate of the points P as x and y, as x is a function of time and y is another function of time t. We can also represent this part as y is a function of x, because when x changes, y also changes. But in rectilinear motion, there will not be change in the there is a linear change, and y is a function of x, and the distance traveled is a function of time, and delta s is the distance traveled by the particle during the period delta t. So the average velocity is delta s by delta t. Then we can resolve this velocity into x and y direction, and the component of velocity in the x direction is the velocity into cosine of this angle. That is, cosine of this angle is delta x by delta s. So the velocity, for velocity we can consider the body is moving from P to P1 at time delta t. So the average velocity is delta s by delta t, and the average velocity in the x direction is delta s by delta t into cosine of this angle between x axis and the velocity, and is represented by delta x by delta t. Similarly, the velocity in the y direction is delta y by delta t. The instantaneous velocity is the is limit delta t tending to 0, delta s by delta t is equal to the derivative of distance traveled by a time, and the velocity in the x direction is dx by dt is represented by x dot, and velocity in the y direction is represented by dy by dt represented by y dot, and the total velocity is the velocity, the vector sum of the compound of this velocity Vx plus Vy, as V is equal to root of x dot square plus y dot square, or some text. These notations are used, that is Vx square plus Vy square, and these are the direction cosines, that is the direction, that is the cos of this angle is the velocity, the direction of velocity, and the direction of x compound of velocity, that is the horizontal direction. Then the average acceleration is, in the similar case with the rectilinear motion, is derivative of this change in velocity by change time, and in the x direction the average velocity is the compound of velocity, the change in compound of velocity in the x direction, and divided by the change in time, represented by delta x dot by delta t, and similarly on y component of acceleration as delta y by delta t. And the instantaneous acceleration as a is represented by ax is equal to dx by dt, it can also be represented in some textbook dvx by dt, as which is also represented by x double dot, and second derivative of x, and ay is dy dot by dt is equal to y double dot, and this ax and ay are is known as the rectangular component of acceleration, and vx and vy or x dot and y dot are known as the rectangular component of velocity. So the total acceleration is equal to the vector sum of these ax and ay, that is ax square plus ay square will gives the magnitude of the total acceleration, and this is the these are the direction cosines. We can resolve this acceleration in another form or another direction as tangent and normal direction of the velocity. That is, we can resolve this acceleration in the direction along the velocity and normal to this velocity. Here, V dash is the velocity at point P, and V1 is the velocity at P1, and these two are the normal at P and P1, and which coincide with point C, that intersect at C, and the C is known as instantaneous center, and this distance from C to P is rho, that is the radius of curvature, and this angle is delta theta, that is this V, the velocity V, and this is velocity V1, and the angle between V and V1 as delta theta. So this angle also delta theta, as these two are the normals of V and V1. Then this is delta V. Delta V is the vector difference of this V1 and V, and Vn is the component of this velocity delta V normal to the V, and delta Vt is the compound of velocity in the direction of this velocity V, and this angle theta is approximately equal to this distance s into this distance s divided by this radius of curvature rho, and Vn is approximately equal to this curve. Okay, as the delta theta is very small, so the Vn is equal to the V into delta theta, and Vt is equal to the difference between V1 and V as delta V. And normal and tangential component of acceleration. The tangential component of acceleration is the average change in the velocity in the tangent direction divided by the time, and this is the average change in the velocity in the normal direction divided by the time t, and this Vt is equal to delta V. This is approximately equal to delta V by delta t, and normal component of acceleration is delta Vn by delta t, is delta Vn is equal to V into delta t is equal to V into delta S by rho. So this can be written as V by rho into delta S by delta t. So the instantaneous velocity components are At is equal to delta V by delta t tending to 0, delta V by delta t is equal to dV by dt, and this normal component is limit delta t tending to 0, V by rho into delta S by delta t is equal to V by rho into ds by dt, and ds by dt is the velocity V. So this V is equal to V square by rho. For the rectilinear translation, this component is 0. This is a particular case of motion, a particular type of motion, and the x is represented in function of t as r cos omega t, and y is equal to r sin omega t, squaring and adding. we will get this as x square plus y square plus is equal to r square, and the motion represent described in the particle described in a circular path, and v is equal to sum of these as r omega, and the direction uh, in the cos of the angle is minus sin omega t, and cos of the angle in the y direction is equal to cos omega t. And differentiating the velocities, we get the acceleration as x double dot is equal to minus r omega square cos omega t, y double dot is equal to minus r omega square sin omega t. And the acceleration a is equal to root of x double dot square plus y double dot square is equal to r omega square, and the direction cosines are minus cos omega t and minus sin omega t, the x and y direction respectively. Next is the projectile motion. Projectile motion is when a particle is projected upwards at an angle less than 90 degree or between 0 to 90 degree is described as the projectile motion. The particle is moving in this path is known as trajectory. Let the alpha be the angle to the horizontal, and let u be the initial velocity of the particle, and a is the point that the projectile hit after the project the time of projection hit at the ground. Okay, this is the compound of velocity in the x direction, that is the velocity along the ground or parallel to the ground is u cos alpha, and this is the vertical compound of velocity u sin alpha, and uh, the O is known as the point of projection, and u is known as the velocity of projection. Then consider the particle at point P at a particular time or any time. Let x be the distance from the y-axis and y be the distance from the x-axis. That is, the point P have the coordinates x, comma y. The velocity of projection in the horizontal direction is u cos alpha, and the vertical compound of velocity is u sin alpha. U cos alpha is constant because there is no uh, resistance against this direction. We are not considering the air resistance, uh, but in the case of vertical direction, there is acceleration due to gravity, and at the maximum point, the vertical velocity will be zero. And y is equal to, we have the equation, for linear motion S is equal to ut plus half a t square. Here S is the y coordinate and u sine alpha is the initial velocity u and a is minus g. So this equation will become y is equal to u sine alpha into t minus half g t square. Then x is equal to u into cos alpha into t, as u cos alpha is constant or the uniform velocity. And time from this equation, time t is equal to x by u cos alpha, and put the value of t in this equation, we get the uh, equation of the trajectory path as y is equal to x tan alpha minus gx square by 2u square cos square alpha. Here this tan alpha is a constant and minus g divided by 2u square cos square alpha is also a constant, and this is in the form of ax square plus bx. Y is equal to ax square plus bx, and this is the path of that is the equation of path of uh, parabola. This equation of a parabola, that is a projectile path is a parabola. At time of flight, you know that y is equal to u sine alpha t minus half gt square, and when the particle at uh, this point A, the y coordinate is 0. So this equation y is equal to 0. This time t is equal to 2u sine alpha by g. This t is known as the time of flight, that is the projectile uh, is at air during the flight. And then horizontal range, that is the maximum distance for maximum horizontal distance traveled by the projectile. U cos alpha is the horizontal velocity, which is constant, and t is the time duration of flight, and the horizontal range is equal to velocity into time. That's the constant velocity into time, and r is equal to u square pi 2 alpha divided by g. And for maximum horizontal range, this sine 2 alpha should be maximum, because there is only uh, variable is alpha, and for maximum sine 2 alpha is 90 degree and alpha is 45 degree. So the maximum horizontal range is u square by g as sine 90 degree is what. Then maximum height of projectile is then when the velocity uh, the vertical velocity at maximum height is 0. So the average velocity is uh, the initial velocity plus the final velocity, that is the velocity at the maximum point divided by 2, and uh, the time taken to reach the maximum height is half of the time of flight, is use sine alpha by g, and the horizontal sorry, the maximum height h reached by the particle is the average vertical velocity into time, and this quotient will become u square sine square alpha by 2g. And hope you all understand these kinematics of uh, curvilinear motion, and the kinetics part of the curvilinear motion discussed later in the next video. Thank you.